When you approach a hazmat incident, you rarely have complete information from dispatch. You may not know the type of material involved, the quantity, or if there is a combination of dangerous substances. Placards may be missing or obscured. Shipping papers may be unavailable, or you may not be able to get a good view of the situation because of fire or vapor clouds or the danger of explosion. Yet, recognition and identification of the hazardous materials involved is critical in order to determine the correct response. R&I is an ongoing process that requires research from several sources. It always begins, however, with an initial assessment of the situation, incorporating all of the information at the scene, location, markings, documents, and eyewitness accounts. In many cases, your first clue, and perhaps your only clue, will be the size, shape, and design of the containers involved at the scene. In this program, we'll examine the types of containers in which hazardous materials are commonly transported and stored. These include highway cargo tank trucks, railroad tank cars, non-bulk containers, and fixed-site storage tanks. Highway cargo tank trucks are involved in numerous transportation-related hazardous materials incidents. The shapes of these carriers will often give you some indication of the materials being transported. The physical characteristics of hazardous cargo can often be determined by the tank truck's cross-section, that is, the way it looks from the rear. Most carriers are either elliptical or circular. The ends of a tank truck, called heads, may provide another clue. Heads will usually be distinctly rounded or flat. Tanks with rounded heads are capable of holding materials under pressure. Those with flat heads usually are not. Pressure cargo tanks transport gases that have been liquefied through compression. These tanks are also known as MC-331s, a motor carrier number designated by the DOT. These tanks have circular cross-sections and rounded heads to help withstand internal pressure. The tank, or part of it, is usually white or highly reflective. Pressure cargo tanks carry liquefied gases such as propane, butane, anhydrous ammonia, and chlorine. Low-pressure cargo tanks, known as MC-307s, are used to transport almost all other types of liquid chemicals. These tanks have circular cross-sections, though from behind they may appear horseshoe-shaped. Since the tanks are under little pressure, the heads are flat. Some low-pressure cargo tanks have catwalks along the top of the tank. Low-pressure cargo tanks carry a variety of hazardous liquid materials, such as flammable and combustible liquids, some corrosives, and poisons, such as acrylic acid, liquid coal, and tar dye. Non-pressure cargo tanks, or MC-306s, usually transport petroleum products. However, this type of tank is also used for other materials. Non-pressure cargo tanks have elliptical cross-sections and flat heads. These tanks are often compartmentalized, with fittings and a manhole assembly for each compartment. However, the manhole assemblies are often hidden from view by a catwalk along the top of the tank. In addition to petroleum products such as gasoline and fuel oil, non-pressure cargo tanks may also carry alcohol, Class B poisons, or liquid food products. Corrosive liquid cargo tanks, or MC-312s, are similar to low-pressure carriers in that they have circular cross-sections and flat heads. However, corrosive carriers are usually noticeably smaller in diameter, have stiffening rings or ribs running vertically around the outside of the tank, and rollover protection around the manhole and fittings. The tanks may be discolored around the loading and unloading areas, as in this example. Frequently carried corrosives include sodium hydroxide, hydrochloric acid, and sulfuric acid. Cryogenic cargo tanks, MC-338s, carry gases that have been liquefied by reducing their temperatures. These tanks look bulky because of the insulation that must be used to keep the cargo cold. Cryogenic carriers have circular cross-sections and flat heads. Piping, valves, and pumps are usually enclosed in a cabinet or station at the front or rear of the tank. These tanks commonly carry liquid forms of oxygen, nitrogen, and hydrogen. There are two other distinctively shaped highway carriers. Tube trailers carry long, thin cylinders or tubes permanently mounted on a semi-trailer. These carriers transport gases under pressure, but always in a gaseous state, never liquefied. Tube trailers typically carry argon, carbon dioxide, helium, hydrogen, nitrogen, oxygen, and refrigerant gases. Carriers that transport dry bulk commodities have large sloping V-shaped unloading compartments at the bottom of the trailer. Dry bulk carriers are used to ship dry materials such as fertilizers, oxidizers, and plastics. Unfortunately, the shape of the carrier won't always be a clue as to the presence or type of hazard. Many dangerous materials are transported by small trucks, semi-trailers, or vans, which may or may not be placarded. Railroad tank cars are used to transport almost any material that can be moved in bulk. While only a small percent of all rail incidents involve hazardous materials, the results are often more severe than in other transportation incidents because of the large quantities that are hauled by rail. Rail tank cars may carry as much as 45,000 gallons of product. In addition, there are often multiple carloads of different hazardous materials in the same train. Some of these materials may become particularly hazardous if they come in contact with the materials in an adjacent tank car. An incident involving a derailment, then, could involve numerous cars and an enormous quantity of hazardous materials. Many rail tank cars are similar to one another, cylindrical in shape with convex heads. But there are some distinctive characteristics. Pressure tank cars are top-loading, with large manways at the top center of the car. And although there are a few exceptions, most pressure tank cars have a protective housing that encloses the manway and fittings. Pressure tank cars may be insulated or otherwise thermally protected. Those without such insulation will have at least the top 2/3 of the tank painted white. Pressure tank cars generally carry flammable and non-flammable compressed gases or poisonous compressed gases. However, they may carry other products such as anhydrous hydrogen fluoride, bromine, or acrolein. High-pressure tube cars are the rail equivalent of the highway tube trailer. Steel cylinders are horizontally attached to the frame of the car. Fittings and safety devices are located at one end. These cars transport oxygen, hydrogen, or helium. Non-pressure tank cars are sometimes called low-pressure tank cars because they carry a variety of liquids and solids at low pressures. Non-pressure cars look like pressure tank cars in that they are cylindrical with convex heads. However, non-pressure cars can generally be distinguished from pressure cars by their visible, unenclosed manways and fittings. Non-pressure tank cars are often used to transport flammable and combustible liquids, flammable solids, oxidizers, and organic peroxides and poison bee chemicals. Certain cars may also carry flammable and non-flammable gases, as well as many non-hazardous materials, such as vegetable and fruit juices. Corrosive liquids are also transported in non-pressure tank cars. However, a corrosive cargo tank can sometimes be identified by discoloration around the manway, or by a wide band of corrosion-resistant paint running vertically around the middle of the car. Corrosives that may be transported by rail include chlorine, formic acid, and hydrocyanic acid. Like their over-the-road equivalent, cryogenic liquid tank cars carry low-pressure, very cold, liquefied gases. The product itself is carried in a steel inner tank. The outer tank is insulated and under a vacuum, which helps keep the cryogen cold for up to 30 days. Cryogenic cars can be distinguished by the absence of an enclosed manway and the lack of exposed fittings. Fittings are located in enclosures at either end of the car or at diagonal corners. Cryogenic rail tank cars commonly carry liquid forms of hydrogen, ethylene, argon, nitrogen, and oxygen. Ton containers, also called multi-unit tank car tanks, can be removed from a rail car for filling and emptying. They're cylindrical, with either concave or convex heads. All fittings are located in the heads. Ton containers can be transported by rail or highway. When transported by rail, the tanks are placed on flat cars or box cars. While these tanks were originally designed to carry chlorine, they're also used to carry anhydrous ammonia, sulfur dioxide, and phosgene. Another type of non-pressure tank car is actually a covered hopper car that is unloaded pneumatically, that is, by applying air pressure. Covered hopper cars are often used to transport dry caustic soda. Not all hazardous materials shipped by rail are found in identifiable tank cars. Some can be found in ordinary wooden or cardboard containers stored in box cars or on flat cars. The shape of the container or carrier may be quite valuable in initially assessing the situation. But this clue is by no means 100% reliable. There are too many variables and too many exceptions to the general rules. Only the shipping papers can provide you with the specific identity and quantity of cargo present. Bulk containers of hazardous materials are relatively easy to identify because of their specific designs. This is not always the case with non-bulk containers. It's impractical to describe all the containers for non-bulk hazardous materials because these products can be found in just about everything, from cardboard boxes to 55-gallon drums. However, there are a few containers that are designed for specific uses. Carboys are glass or plastic bottle-type containers used almost exclusively for hazardous materials. Carboys are encased in specially cushioned boxes to protect the contents. Corrosives are usually found in these containers. Cylinders can store various hazardous materials, many of which may be under pressure. Short, broad cylinders are usually used for low-pressure materials. Tall, thin cylinders for high-pressure materials. While cylinders are most commonly associated with compressed gases, they can also contain flammable or combustible liquids, poisons, radioactive materials, or corrosives. Dewars are non-pressurized, heavily insulated containers with inner and outer shells. They're used to store cryogenic materials, such as liquid nitrogen, oxygen, and helium. Packaging for radiological materials depends on the level of radioactivity involved. Type A, or low-level radioactive materials, may be found in glass bottles housed inside boxes or drums, which may include shielding. Type B, or higher-level radioactive materials, require more shielding and secure packaging, such as steel-encased lead containers. Packaging for radioactive materials, as for all hazardous materials, must be well marked. Unless a hazardous material is in a labeled or otherwise easily identifiable non-bulk container, you have no way of knowing exactly what you're dealing with. Don't be deceived by the size of the packaging. Hazardous materials in fixed-site storage tanks can sometimes be identified by the type of storage tanks found at the location. Tanks are designed to withstand the specific properties of the products they're intended to store. For example, as with other types of storage containers, rounded tops or ends and pressure relief valves on tanks indicate that the contents are probably under pressure. The most common fixed-site storage tanks are cylindrical, with vertical walls and either flat or cone-shaped roofs. Their contents are usually flammable, combustible, or corrosive liquids, such as petroleum products, although they can be used to store non-hazardous materials as well. Dome roof tanks also have vertical cylindrical walls, but they differ from other vertical storage tanks in that they are taller than they are wide, and their roofs have an obvious rounded shape to accommodate internal pressure. These tanks are often used to store flammable and combustible liquids such as fertilizers and chemical solvents. Floating roof tanks are also vertical tanks, but they're designed so that their roofs actually float on top of the stored product. This prevents the buildup of dangerous vapors. Some floating roof tanks, such as this one, are open. Others have an internal floating roof and an exterior stationary roof. You can identify these tanks as having internal floating roofs by the vents at the top of the tank shell. Floating roof tanks are used to store flammable and combustible liquids such as gasoline. Hazardous materials are sometimes stored in horizontal tanks. Horizontal tanks are usually set on blocks or legs and have rounded or flat ends depending on whether or not they are pressurized. Pressurized horizontal tanks store gases such as butane, propane, anhydrous ammonia, chlorine, sulfur dioxide, and hydrogen chloride. Non-pressurized horizontal tanks store flammable and combustible liquids, such as fuel oil and diesel fuel, as well as corrosives, poisons, and solvents. Spherical tanks are ball-shaped and usually painted white or another highly reflective color. They may, however, be covered by a sheet metal structure, giving them the appearance of a vertical tank. The presence of pressure relief devices on top of a spherical tank means it probably contains a pressurized gas, such as methane, propane, or LPG. If there are no such valves, the tank may be storing cryogenic liquids. Cryogenic tanks resemble dome roof tanks because they are taller than they are wide, and they have rounded roofs. However, these tanks are heavily insulated and rest on legs rather than directly on the ground. Typical cryogens include oxygen and nitrogen in liquefied form. Underground storage tanks can contain either liquids or gases. You can usually identify their location by the above-ground gauges, vents, controls, and fill points. Underground tanks can be found at service stations and other locations where petroleum products are used. These tanks most commonly store LPG, gasoline, and fuel oil for home heating. A knowledge of hazardous material containers can be valuable in your initial assessment of a situation. However, this is tentative information. It will enable you to make an educated guess only and will always be subject to change when further information becomes available. Remember, these clues must be used in conjunction with reference materials, documents, and reported information before action can be taken.